What's going on, guys? Welcome to Python Regular Expressions Made Easy Part 16. In this video, we're going to take a look at negative lookarounds. So in the last video, we dealt with lookarounds, but it was more on the positive side. Positive look ahead and positive look behind. So in this video, we'll focus on the negative portion of lookarounds. Alright, so let's get started. So the first thing we're going to do is just remind ourselves of the syntax of negative look-aheads and negative look-behinds. So the syntax is a question mark followed by an exclamation point. And with negative look-behind, it's the same thing, but we just have that's a less than sign. Yeah, so a less than sign in between the question mark and the exclamation point. So let's take a look at an example. Well, the first thing, actually, I just want to remind you guys that a negative look ahead or a negative look behind doesn't consume any characters. What a negative look ahead or look behind does is it makes sure that this particular pattern or subpattern isn't within our main pattern. So in other words, it makes sure that whatever is within this negative look around, the subpattern, it is not included in any of our outputs. So we'll have a long pattern, and the negative look around is just going to say that, okay, we don't want this to be part of our pattern. So we want to pull out everything, but if this particular subpattern is there within the string, we don't want to output it. So when I give some more examples, this will become a lot more clear. So the first thing we want to do is run this string. So let's take a look at the string. Okay, so the string is just a multi-line string, and it has the word occupation followed by a colon and then some sort of occupation. So there's party planning, baking, cook, publicist, entertainer, baker, and I think you pronounce it Pierrot, so which is a type of clown. So you have all these occupations, right? Now, what we're going to try to do is we want to pull out all the different types of occupations except for anything related to baking and cooking. So in this case, we have baking, cook, baker, and baker. So we have these four different occupations that are related to baking and cooking. So say we wanted to pull out everything except for those particular occupations. This is a pretty small string, but let's just imagine we have thousands and thousands of occupations. Let's just imagine the string was a really lengthy string consisting of thousands and thousands of occupations. So if you imagine that, then negative lookaround would be a lot more useful. Okay, so this is our pattern now. So what we're going to do is we want to pull out the occupation followed by a colon, and we're going to use a negative look around. Okay, so the negative look around is going to, this one's a negative look ahead. So remember, there's two negative look arounds. One's a negative look ahead and one's a negative look behind. So the negative look ahead is going to say, in this case, what we're saying is we have occupation followed by a colon and then a space, and then we want to make sure that whatever is following the space is not a baker, is not baking, or is not cook. So if you take a look at our string, we have occupation, colon, space, then we have a party planner. In this case, we have baking. In this case, we have baker, and in this case, we have a lowercase baker. But since I'm using a flag, ignore case, this lowercase baker shouldn't be a problem. So essentially what this negative look ahead is doing, it's saying is we want to make sure that whatever follows occupation, colon, space is not a baker, baking, or cook. And if these conditions are satisfied, we want to pull out entire string until the end of the line. So in this case, if the condition is satisfied, okay, this is not baking, okay, so we'll pull it out. This is baking, we're not going to pull it out. This is cook, which is one of the choices, so we're not going to pull that out. And then the rest of them, publicist, entertainment, and this, I forgot how you pronounce it. This also will get pulled out. So let's just run this and see what happens. Okay, run this. And I run re.findAll with the pattern and string. And if we run this, let's see what we pull out. So we pull out occupation, party planner. We skip the baking. We pull out the publicist, the entertainer. We skip the two bakers because we have ignore case. It doesn't matter if it's uppercase or lowercase. and we pull out this this last one, PRO. Okay. Anyway, so as you can see, this works perfectly, and that's because we're using negative look ahead. So negative look ahead says as long as these patterns or subpatterns are not following occupation, then we want to consume the entire string. So remember, this is all characters, including spaces, and this plus is a greedy quantifier. So this doesn't do any consumption, but this does. So this will consume all the characters and then output it. Okay, so this was an example of negative look ahead. Now I have an example of negative look behind. And this example is actually, I came up with this example on my own, but it turned out to be a little more difficult than I expected. So hopefully it's not too bad for you guys. But anyway, so we have a string that starts off with a full invitation list, and then it has a bunch of names. First it has either if the person's a guest or holds some sort of occupation at this party, and then it's followed by their name. So here we have guest Ashley Jackson, guest Maria Jackson, guest entertainer baker, party planner, publicist, baker. Okay, so we have a bunch of names, right? So we have this list of people, and say we wanted to pull out everyone except for the baker. Okay, so in this case we have 2 bakers, right? As you can see, we have a bunch of different types of people, or in this case we have an entertainer, we have a guest, we have a party planner. So we can't actually use or, because if we put something like or guest or entertainer or party planner or publicist or blah blah blah. So just imagine this list is really large and we have like 30 different types of categories. So to use an or statement to differentiate between each sort of category is very cumbersome. Not the cleanest way to write the code. So in this case, we'll use, once again, a negative look around. In this case, this is going to be negative look behind. All right, so the negative look behind is essentially this portion, right? So we have a question mark followed by a greater sign, less than sign, and then followed by an exclamation point. Now we have the word baker followed by a colon and space. So essentially what we want to do is we want to make sure that this is not preceding the name. So essentially we want to pull out the name, but we want to make sure that baker is not preceding the name. Now this regular expression is a little complicated. So what I'm actually going to do is I'll actually simplify this so I can show you exactly what each part is doing. So the first thing we'll do is we'll get rid of this B, and we'll get rid of this question mark, not question mark, dollar sign. All right. So if we just take a look at this, I want you to ignore the flags for a second. It doesn't really matter. So we're essentially asking for the name, but it can't be preceded by the word baker, colon, and a space. So we want to make sure that the name is not preceded by this this portion. So if we just run this regular expression as it is, we'll run into problems. And the reason why is, remember, this doesn't consume anything. So the actual portion that consumes something is this portion here. So this is essentially saying a bunch of characters followed by a space, followed by a bunch of characters. So a bunch of characters, well, this will, bunch of characters followed by space, followed by a bunch of characters. So this will work. This also works, a bunch of words followed by a space, followed by characters. Okay. The problem comes with the bakers. Remember, this code is saying we don't want it to be preceded by a baker colon space. So if we look here, baker colon space, right? We don't want it to be preceded by that. So this C actually is actually preceded by this baker colon space. So the problem is this C is not going to get captured. However, if you just look at this H, if we start from H, HRIS space Jackson. Remember, these are not capturing words, these are just capturing letters. So we have HRIS space Jackson. This actually satisfies this regular expression, and it actually satisfies this portion. So what's going to happen is we're actually going to pull out Riss Jackson and the other baker, Ashley Sanders. We're going to get rid of the A and just pull out the Schley Sanders. So if I run this, and let me just push this up, and we'll run this. Let's see what happens. Okay. All right, so we get remaining party, baking occupation. Oh, oops, I forgot to run this string. So let me run the string and let me just run this again. Okay, so we get full invitation because it's not preceded by a baker and it's word space word. So this entire thing gets captured. Remember, these are greedy quantifiers, so it tries to capture as much as it can. Okay, so Ashley Jackson, Maria Jackson, Bob Sanders, Bill Smith. Okay, so the first baker, Chris Jackson. So Chris Jackson doesn't get consumed, but it's HRIS Jackson. So just as I had shown a little earlier, HRIS Jackson gets consumed. Okay, so here's another problem. See, party planner, right? Because it's not preceded by baker in this case, and it's word space word. So word space word, this actually satisfies that portion. And then we have Seema Patel. So Seema space Patel, Seema space Patel. This also satisfies this condition, and it's not preceded by this baker. And once again, instead of Ashley Sanders, we get Shley Sanders. SHLEY is not preceded by baker colon space. It's preceded by just a name. Alright, so that's why we have to use word boundaries. So word boundaries make sure that there's a space to the left, and this helps us to pull out just the names. So if I just bring this up, and if, okay, so there's a couple of more things I want to go over, but first we'll just run this, and then we'll run re.findAll. Okay, so in this case we pull out we pull out Ashley Maria, Bob, Bill, Michael Johnson. We skip Chris Jackson. We get Seema, and we skip Ashley Sanders. So this is actually perfectly pulling out all the names that are not related to baker. So this works perfectly. Now, to make this work, I added a boundary, as you can see. So the boundary makes sure that there's a space to the left of the word. So in this case, Chris doesn't have a space to the left. It has a C to the left if it just pulls out HRIS. So this doesn't work. And the same thing with Ashley. It doesn't have a space to the left. It has a alphanumeric character, so this doesn't work. Now, the other thing I had to use was a multi-line with a $sign. What a $sign essentially does is it makes sure it's the end of the string. So in our case, it's not the end of the string, it's just the end of the line. And that's where this re.m comes into play. So the re.m actually gives this $sign some more characteristics, or it sort of expands the options of the $sign. When we add re.m, it signifies either the end of the string or right before the end of the line. So I'm going to show you exactly what happens if we get rid of the $sign. So first I'll get rid of the $sign and I'll run this pattern. Okay. So we pull out full invitation again because, it's not at the end of the line or end of the string. So as you can see, full invitation is not the end of the line or end of the string. So by removing this $sign, we get rid of that constraint. So we get rid of that constraint and we pull out things we don't actually need. Because remember, all these are at the end of the line. We only want to pull out the ones that end at the end of the line. Okay. So let's see what we pull out. So we pull out full invitation. We pull out all the names except then we have a problem here. We have Jackson, a new line, party. So essentially this is Jackson, new line, party. This \s actually represents new lines, tabs. It represents all types of spaces, a whole range of spaces. So new line, tabs, etc. are all represented by \s. So that's the other thing. So by adding the constraint, the $sign constraint, we prevent this problem as well, Jackson and end party. So here, since this doesn't have the constraint, it does Jackson space party. So this also gets satisfied. By adding the $sign, we constrain this regular expression to be at the end of the line. So in this case, the only thing that will get pulled out is Chris Jackson. But in this case, since it's a baker, it's not going to get pulled out. And by adding the $sign, we prevent something like Jackson space party. Yeah, so it constrains this regular expression to new line, and that's why we prevent something like Jackson end party to be pulled out. And essentially it's already multi-line. Remember the dollar sign, let me just add this dollar sign again. Okay, add this dollar sign. So if we don't add this re.m, if I get rid of this, you're going to see it doesn't really work. Actually, we should get an empty string. Let me see. Okay, so we get an empty list. So it's not going to work. Essentially, we're looking for this portion at the end of the list, end of the string, sorry, at the end of the string, and not for each new line. Yeah, so by adding the re.m, this regular expression also applies to the end of the line. So in this case, we're looking at each line instead of just the end of the string. So each line can satisfy this regular expression as well, instead of just being the end of the string. Yeah, so by adding a boundary and by adding this dollar sign with re.m, we were able to pull out what we wanted, which is every name from the invitation list that's not associated with a baker position. Okay, so now in this case we have a first name, last name, right? So it's pretty simple. We were able to use \w space \w. But say we had names that had composed of 2 words, some names composed of 3 words. Say that some people had something like a middle name in the invitation list as well. So in our case here, it's very easy to take care of something like that as well. So I added, instead of Maria Jackson, I added the name Maria once again. So it's Maria Jackson, just to show you that we can pull out Maria Jackson, as well as all the names that just have a first name and last name. Take the same thing. So this pertains to the first and last name, and this regular expression pertains to any guest that has a first name, middle name, and last name. So essentially I'm using the or sign. So either pull out first name and last name, or pull out a first name followed by a middle name followed by a last name. And what prevents something like Maria to be pulled instead of just Maria Jackson is, of course, this dollar sign. So this dollar sign always makes sure that the name has to end at the end of the line. So just by using this or symbol and having, in this case, word space word, which is looking for 3 words instead of 2, we're able to pull out all types of names, whether they be first name, last name, or whether they be first name, middle name, last name as well. And if I run this, let's see, re.find all. Okay. Wait, it didn't pull out Maria Jackson? Oops. Forgot to run the string. There we go. I was wondering why Maria Jackson didn't get pulled out. Okay. And in this case, we pull out Maria Jackson. So it seems like it works. Simon Patel. We don't pull out Ashley, and we don't put out Chris. We pull out Michael, Bill. Yeah, so it works. So in this case, we're pulling out Maria Jackson. Okay. Just one last example is going to be just if you want to pull out the entire phrase. We want to pull out the entire phrase, as long as it's not composed of a baker. So as long as the occupation is not a baker, we want to pull out the entire phrase. So we want the occupation as well as the name, whether they be a guest or a publicist or blah, blah. In that case, we'll use a look ahead. So if you want to pull out the entire string, what we'll do is we'll use the negative look ahead. So instead of, earlier we used the negative look behind, in this case we use the negative look ahead. And essentially what we're saying is at the beginning of the string, so we're going to start at the beginning of the string, we don't want it to start off with baker. So we're at the beginning of the string. As long as it doesn't start off with this, what we want to do is pull out the entire string, and it has to end. It has to end in some sort of word. Yeah, so essentially I'm just adding this portion. It has to end in a word. I think because of this portion. I think I wanted to exclude this portion. Anyway, we'll run both cases. So essentially what we're saying here is that we don't want it to start off with baker, and if it doesn't start off with baker, we want to pull out the entire string. So let's just run this. Then re.find all. Let me just run this, and we pull out guest, entertainer. So essentially we're pulling out everyone. Four guests. So we have 4 guests, 1 entertainer, 1 party planner, and 1 publicist. So that's 7. And let's see, 1, 2, 3, 4, 5, 6, 7. So essentially we're pulling out everyone. So that's one way we could pull out everyone if you're not looking for a certain word. If you're trying to exclude, in this case, baker. And let me just show you exactly why I added this portion. So we'll just copy this. And let me just run this again. What I'm going to do is just get rid of this portion. And if I run this here, so as you can see, we pull out this full invitation list. And since this list ends in a colon, just by ensuring this, just by adding the constraint that has to end in a alphanumeric character, we get rid of the first entry. So run this, and as you can see, this works perfectly. All right, that's pretty much it with negative lookaround. There's actually one little thing that I will probably cover in the next video. It's going to be a short video. It's regarding variable width. Like there's some constraints that with regards to look behinds that you can't do when it comes to Python regular expressions. So there's certain constraints that I want to go over in the next video. Okay, so in this video we went over negative look ahead and negative look behind. We had 3 different examples. So we had the first example, we want to pull out all of the occupations as long as it's not baker, baking, or cook, anything related with baking or cooking. So essentially we want to pull out all your occupations that are not revolving around some sort of cooking. So baking, cook, baker, bake. We excluded all those and we used negative look ahead to accomplish that. And here we use negative look behinds to pull out all the names associated with titles or jobs not related to baker. Yeah, not related to baker. So we did that successfully, and then we have we just expanded upon that example just in case the names have a first name, middle name, and last name, which we took care of with this OR pattern. And finally, if we wanted to pull out the entire phrase, pull out an entire phrase that doesn't contain a certain word, in this case it doesn't contain the occupation baker, we were able to do that as well. So yeah, so that brings a wrap to this negative lookarounds. In the next video, I will go over just a couple of constraints you have when with look behinds. And yeah, so we're almost done with the regular expressions playlist. I think after that video, I'm probably done with all the basics regarding Python regular expressions. All right, so I will see you guys next time.